Hello, good afternoon, everyone. I don't know where my co-chair is because she is supposed to be moderating this and I will be timekeeping. So I think we can just start the session. Our first speaker is Giudita. I think she's online. I'm not sure she will be, she will be do you want to present online or play the recording? It's a recorded, okay, so a reminder that this session is a virtual session, so it's either presenting online or recording. Yeah, okay, so let us start with the first presentation.
Good afternoon, everyone. My name is Giudita Parolini, and I am virtually enjoying the conference from Berlin, Germany. I am based at the Naturkunde Museum in Berlin, and together with my colleague Mareike Petersen, I am working on a research project on the sustainability of data practices and infrastructures in biodiversity science. This talk wants to be a reflection on sustainability from the perspective of biodiversity informatics and a call to action for the biodiversity community to get involved in discussing the complex topic of sustainability. Defining sustainability is not an easy task. It is not an easy task because the word sustainability is literally everywhere. We talk about sustainable development, and you probably already came across the sustainable development goals set by the United Nations, but we also talk about sustainable lifestyle, sustainable agriculture, sustainable finance, and so on. These are all very different fields and activities. Sustainable cannot mean the very same thing in all these cases, but at the same time there must be common elements that justify the use of the adjective sustainable in all these cases. The philosopher Jeffrey Ramsey argued that we need to come to terms with the absence of a unique definition of the word sustainability, and accept that the concept is multifaceted and that sustainability takes its meaning from its context of use. In the end, every field will need to have its own operational definition of sustainability, a definition that describes how we go about implementing sustainability and not on the theory of sustainability. That said, even in the absence of a unique definition, there are certainly common elements in the multiple uses of the word sustainability. Two of these elements stand out. The first one is the temporal perspective. Sustainability is defined in relation to the present, but always considering the future consequences of today's actions. The second element that constantly returns in the definition of sustainability is the interplay of three dimensions: economic, environmental, and social. This is clear in the United Nations Sustainable Development Goals, but it is equally present in any discussion on sustainability, be it in agriculture, finance, or other fields. Keeping these two common elements of sustainability in mind, I would like to discuss how the challenges faced by biodiversity informatics are sustainability challenges. All data-driven fields in and beyond science are currently under pressure due to the constant increase in the amount of digital data they need to deal with, the growing complexities of data regulations, and the competing interests of data stakeholders. In biodiversity informatics, three aspects stand out as especially problematic. First of all, digital data in biodiversity informatics have literally exploded during the past decade. The plot in the slide is extracted from GBIF Global Data Trends and shows the number of occurrence records available for each year since 1950. Comparing the figures for July 2024 with the figures for January 2020, it is evident that the number of yearly records has more than doubled in this time frame. But the issue is not just that biodiversity data have become many more, the issue is also that biodiversity data are more and more diverse. There is an increasing share of media data, images, videos, audios, 3D models. Also, storage and management requirements are very different compared to standard tabular data. Therefore, data integration and aggregation have also become more complex. In addition, biodiversity datasets are becoming larger and larger. The largest dataset on GBIF, the eBird observation dataset, for instance, has over 1.5 billion records, and the Darwin Core Archive for download is 1 terabyte. A user that can rely only on a download speed of 100 megabit per second, which is already twice the lowest internet speed on offer in the German telecom market, will need about 24 hours to download the data. After the data has been downloaded, the user will then need 5 terabytes of dedicated disk space to unzip the file. These are resources not available to the average user. But having too many, too different, and too large digital datasets in biodiversity informatics is just one of the issues. The data infrastructures of biodiversity informatics pose also multiple challenges. Apart from a few notable exceptions, these infrastructures live on project-based funding that makes their continuing existence and further development uncertain. These funding constraints also hinder the possibility to scale up these infrastructures and cater properly for the increased amounts of biodiversity data that need to be stored, managed, and shared. In addition, while data management plans are becoming more common, software management plans and software sustainability plans, that is, documents that list and standardize the practices for code maintenance, software documentation, user support, and so on, are still not a routine tool in biodiversity informatics, and this lack of standardization is also affecting infrastructural development. This is especially problematic considering that the number of data stakeholders in biodiversity has been growing constantly during the past few years. Alongside the scientific community, biodiversity data are now of key interest, for instance, also for the finance sector, because biodiversity is one of the aspects constantly examined as part of the environmental, social, and government assessments, in short, the ESG ratings, that pinpoint a company as a good or bad investment by considering its exposure to sustainability risks and its impact on people and the environment. Data infrastructure in biodiversity informatics should also accommodate the needs of these users. These challenges of biodiversity informatics are sustainability challenges because the choices made in the present about data and infrastructures will have consequences in the future. Technology and vendor lock-in come to mind as possible examples. Back compatibility of data and code must be ensured to guarantee continuous access to biodiversity data and the viability of biodiversity informatics infrastructures. If services are bought from a provider, then the difficulty to switch to a new vendor should always be assessed to be sure that organizations keep the freedom to decide how they manage their data and build their infrastructures and where they want to host them. The challenges of biodiversity informatics are sustainability challenges also because, borrowing from the United Nations Sustainability Agenda, they have to do with people, planet, and prosperity. The ecological impact of biodiversity data and the infrastructures that are used to manage and share them is growing proportionally to the increase in biodiversity data. This makes urgent an assessment of data management and data sharing practices adopted to ensure that environmentally conscious choices are made when taking decisions about hardware and software tools. Environmentally conscious choices that, for instance, prefer solutions that consume less energy will also have an impact on the prosperity aspect, as they will help to save money in the long run. The people perspective is also crucial. If biodiversity data are collected and shared while keeping in mind the necessities of multiple stakeholders, the user community will become larger, and this in turn will offer the chance to develop fairer cost contribution agreements for running data infrastructures. Now, coming back where we began, that is, the operational definition of sustainability that can suit the need of biodiversity informatics, such definition can only be the result of a community effort. TDWG and SPNHC are a key part of the biodiversity informatics community, and their members can offer very valuable contributions to define practical criteria and recommendations for implementing sustainability measures. You can get involved in many ways, for instance by proposing use cases, discussing best practices, or simply by asking questions on sustainability. Mike and I were not able to join the conference in person, but we would be delighted if you get in touch and we can continue to discuss about sustainability. We hope that this talk is the beginning of a fruitful conversation. In conclusion, let me thank you for attending the talk, thank the conference organizers for making virtual participation in the meeting possible, and the German Research Foundation for sponsoring the project.
Okay, thank you, Gyudita. And she's online for question, if anyone has any question. No? Okay, then we thank her for the presentation, and we can start our next talk. And this is also a recorded talk from Omas. And Omas is also online, so probably can take any questions after. So let us. It's not, is it? Okay. Hello, Omas.
Hello.
Hello, would you like to present online?
That's interesting because I uploaded MP4 file.
I seen his recorded video in the public folder. Let me. Please wait for a second.
Yes, thank you.
Hello, Omas. I think there's a technical issue. Can you can also share your screen and then play the recorded video. Is that okay for you?
Yes, I will share. I will start. Thank you.
Oh, okay.
Can you see my screen?
Not yet. Ah, okay, we can see your screen now. Thanks. Okay, cool. Thank you.
And communication of taxon. Taxon hypothesis paradigm covers the construction, identification, and communication of taxa as data sets of individuals. And defining taxa as fixed data sets of individuals and their traits will make taxon identification and probably most importantly, communication of taxa precise and reproducible. Here you see very simple table which can be treated as taxon description based on individuals and their properties. And of course, you can have in your table all kind of taxon criteria or species criteria if you are working on species level. So you can use morphological, anatomical, biochemical, physical, and today probably most importantly molecular criterion, which are basically nucleotides. And this is, we can say, the same type of taxon description in digital visualization. So we have individuals, every line represent a single individual, and states of the traits are in columns. And in this case, on the screenshot, you will see only nucleotide. So it's DNA sequence, where every column can be treated as different character. And working with taxa like this will allow data sets with standardized and atomized traits to be used digitally, at first in identification pipelines, of course. And secondly, because it is fixed, you can communicate those data sets through persistent identifiers like DOIs. And we see that those data sets are also very useful in the context of formally undescribed species, where actually data are available from eDNA data, but species is not described formally. It means there is no full name. And then, of course, persistent identifier can be used in parallel to taxon name. I will give you example. Unite community implemented Unite taxon hypothesis paradigm. And basically, in few words, Unite community takes all freely available public sequences from INSTC GenBank databases and aggregate them, compute them into species hypothesis, so which is specific case of taxon hypothesis, assign to them DOIs, and then generates different reference data sets to be used in identification pipelines, and also which help to publish eDNA data as taxon occurrences in different data portals. I will just say a few more words about DOIs used in Unite species hypothesis. And all SHs, all species hypothesis, it's nearly 1 million DOIs are assigned to those species hypotheses. And they can be used, of course, then in scientific communication studies and data sets. And here you can see visualization of one species hypothesis in Unite database. It has full species name available, Rhizoporgonveri, but it has also DOI, which is fixed on fixed number of individuals with fixed number of sequences or traits. And those DOIs of the data sets, species level data sets, are implemented now for 6 years in GBIF taxonomic backbone. And they are implemented for fungal kingdom. Here you can see one of those DOIs assigned to SHs on left hand. It is a page for SH in GBIF. You may recognize that there is only genus name available, but of course the persistent identifier solves the communication issues. And you can see also on the map that there are different findings of this species hypothesis from Europe. It means that different studies have been using UNITE resources for identification, and they published their findings in GBIF using those DOIs of the species hypothesis. And on right side, you see the same species hypothesis DOI page. So, as I said, implementing DH paradigm will to some extent remove the impediment to hastily discover and formally describe all extant species. In that, the DH paradigm allows discovery and communication of new species and other taxa also in the absence of formal descriptions. And this small table for 3 species is published 2020, but there are hundreds of such cases where species hypothesis was published in UNITE, DOI was assigned, and then it was possible to actually publish in GBIF, or it was possible to communicate those species without formal description. And we see on left column that those species were formally described 2 or 4 years later after they were actually became available in as UNITE species hypothesis. So, as I said, there are hundreds of such cases, and probably, as much as we know, in most cases, they are not formally described. And one reason is that there is no specimen available for the sequencing. And another feature I would like to demonstrate is so-called third-party curation of those individuals in taxon hypothesis. Project Bicycle developed a specific pipeline for curated individuals, which then can be published back to gene banks. And it works so that UNITE individuals in species hypothesis are curated. For example, you can add new name or locality, coordinates, metadata, and then you can publish this curation to European Nucleotide Archive. And what we see is that those species hypothesis data sets are increasingly utilized in taxon identification pipelines and in communication of eDNA data also in GBIF. If you want more information, please inspect our UNITE recent paper in Nucleic Acids Research Database issue. We did also preliminary comparison of DH paradigm implemented in the UNITE platform with the taxon concept schema developed by the DCS task group. And our conclusion was that actually it is not very difficult to implement also DH paradigm in the current schema of DCS. Thank you.
Thank you, Omas. Sorry for the trouble. Anyone has any question for him.
I don't really have a question, but I would like to note that I asked Urmas to give this talk in a symposium that I was organizing about computationally tractable circumscriptions in TCS. And apart from Urmas, all other speakers didn't deliver abstracts. So the symposium fell through, so I would like to thank Urmas very much for giving this talk, and I think it stood up very well by itself. And Urmas, we will talk much further about implementing the taxon hypotheses in TCS as well.
Thank you, Niels. Yeah, I think it was okay for me.
Okay, anyone else has questions or comments? Please.
Yes, we met with Urmas a couple of weeks ago in the International Mycological Congress, and there were attempts to formalize DNA and sequence-based formalization of the names, and that failed. The special committee will be formed and so on, but I guess what is important to realize from Urmas's talk that formalization of the sequence-based names, it actually doesn't block or doesn't improve the databasing or the scientific progress. For formalization of the names is needed outside science and outside kind of TDWG intensive work for the PR, for counting species, for conservation work. This is also important because it makes the microbial taxa more visible, legally recognized. But I guess what I'm very happy to see in GBIF and outside is that the taxon hypothesis and species hypothesis based taxa are very much functional and they're machine readable here and now for a few years now. So this is fantastic, and we are very grateful in GBIF for the Unite and Pluto F team for doing this work. Thank you.
Okay, because of time, I think we can move on to the next speaker. Okay, so our next speaker, thank you, Urmas. Our next speaker is Michelle. I see that she is also online and she has a recorded video. Okay, so we can start with Michelle's presentation.
Thank you for the opportunity to present on our work today. I'll be talking about the value of community involvement in assessing the management and care of South Africa's natural science collections. The Natural Science Collection Facility is a network of 16 institutions in South Africa, 8 museums, universities, science councils with more than 80 collections, over 16 million accessions, 180 staff, and it's coordinated by the South African National Biodiversity Institution. The NSCF is funded by the Department of Science and Innovation as part of the National Research Infrastructure Program, but the collection institutions are funded by various government departments that they fall under, so higher education or health, environment, agriculture, and arts and culture. The annual budget of the NACF is about $1 million US, but this is just for the network functions, not for the staffing and normal operations of the participating institutions. That's covered by the government department they fall under. The NACF hub team is 10 core staff, and that is covered from the budget. The NACF was established in 2017. After a national assessment of the collections in 2011 highlighted problems, including lack of policies and procedure documents, low staff morale, fragmentation with little interaction across or even within institutions, and no national coordination or strategy, and no training courses. One of the main objectives of the NACF is to secure and make collections accessible. And one of the first things we worked on together as a community was to develop this Collections Management and Conservation Manual, which was published in 2021. It includes policy guidelines, procedures, standards, templates for documents, and covers accessioning, deaccessioning, documentation, data, images, access risk and disaster management, health and safety, and ethics and permitting. We also developed a virtual training course based on the manual, and that ran over 18 months with webinars, discussion forums, and assignments, and there were 54 people who participated in it. The NACF has also invested in the institutions, collection storage facilities, and consumables. And so after all of this work and investment over 5 years, the next logical step was to assess whether these interventions have had any impact. So to look at what is the state of collection management and care now. To do this assessment, we took a bit of a different approach. The 2011 assessment had involved just having one external person who'd gone to each collection with a questionnaire and completed it. But from the start, the NACF had recognized that unless the staff morale and the lack of interaction were addressed, there was limited chance of any impact of other interventions. We also recognized that there was great diversity in the institutional cultures and also in their governance models and their size. There's also a diversity of people, so different races, ages, qualification, gender, roles, and there were issues of exclusion, oppression. And in South Africa, there is a legacy of colonialism and apartheid that does impact on the work environment. So we're dealing with a very complex environment. The NACF is transformatory. It's transforming from fragmentation to collaboration, from having no standards to common standards and practices implemented, and also fostering a sense of accountability. Since 2018, we've involved specialist facilitators and had a significant investment in really building a community, which we believe was essential for the effectiveness and the sustainability of the NACF. So a collections assessment had to be inclusive and contribute to strengthening the network rather than being divisive or destructive or negative. But it still has to produce credible data. So we developed what we call the Ekokwana initiative. So Ekokwana is a small group in isiZulu or isiXhosa. And we recognize that the assessment of the collections has to be a journey. It's not just the production of a report. And the values, it must be credible, it must be inclusive, transparent, transformative, and embedded in the institutions, and not something that's just done by an external third party. We had many engagements with staff at all levels to build and get input, explain, generate interest, and get buy-in and support. We had an online forum and information sessions, workshops, and social media groups. So the assessment process involved an online questionnaire that was based on the manual with 185 questions covering storage environments, consumables, curation practices. And this questionnaire was completed by the collection staff online. It was a self-assessment. They submitted documents as well, online, registers, policies, procedures, standards, reports, and that was assessed or reviewed by the NACF Hub team. We also had orientation workshops at the beginning to provide guidance on how to complete that questionnaire and how to upload documents and also to address concerns. Once the self-assessments had been completed, we did a moderation process. So the Hub team members visited the collections and reviewed. They went through the questionnaire with the staff who had compiled it, who'd done the self-assessment, and they worked with them to understand where there may be discrepancies and why. And so it was really a learning process. And we also involved observers from other collection institutions in the moderation. The data were all compiled and analyzed, and then feedback compiled for each of 60 collections that we assessed, and then one for each institution, and then an overall report. So for the collections, there was a risk assessment, the extent to which risks are mitigated or managed. Also an assessment of the extent that the manual practices and standards have been implemented, and also document development, the extent to which that's complete. So that was done for each collection. And then for the institutions, there was a summary of the different collections in them and the analyses for those. Also, an assessment of their planning, their health and safety, their risk management, and their resourcing. So those are things that are managed more at an institutional level. We highlighted good practice and also identified gaps and major risks. So before we distributed the feedback, we did meet with the institutional managers to get input on who should receive that feedback and how should the overall report be distributed. Should it go to their governance structures? Should it go to the department? Who should it go to? We also ran sense-making workshops, so these were regional and cross-institutional, to support understanding of the analyses, to discuss main findings and trends, and for institutions to consider how they would go about addressing the gaps and the challenges identified. We really found that there was a sense of appreciation for the feedback and the work that had gone into the production of the reports, so it was a positive response. And in most cases, there's willingness and commitment to working on addressing the challenges and to collaborating to do this. So going forward, the NACF Hub team have also had several reflective workshops and discussions, and really what it means is by working with the community through this whole process and having different workshops, and the moderation process has given us great insights into the social challenges. So leadership issues, team dynamics, psychological safety in some of the institutions. We understand the lack of resources. There's a shortage of staff and funds. But what we also saw is that there's a lack of planning and resource management. So going forward, the facilitators and the Hub team will assist with planning and other social challenges. We've developed a tracking tool that will allow collection staff to track progress with addressing gaps identified, and we will be setting up a community of practice to share expertise and provide support across institutions. So I'll end there, and just to thank the managers and staff at all the institutions that participate in the NACF, and our organizational development and transformation facilitators, and then also our staff. Thank you.
Thank you, Michelle. And Michelle is online if anyone has any question or comments. No? Okay. If no, then we can move on with our next presentation. Our next presentation is from Erica. I see that she has a recorded video as well. Before this, I want to mention the last two presentations of this session. We couldn't get their recorded videos, and so far they are not online at the moment. So probably there's no two presentations at the last of this session. So at the meantime, I will just watch out if they are online. Okay, so let us, Erica is also online, and we can start with Erica's presentation.
Hi, I'm Erica Anderson, and I will be speaking to you today about anthropogenic biases and their impact on mineral collections and the role of mineral aesthetics. So anthropogenic biases are biases introduced by human interaction, mostly through the decisions we make, whether that is where we're sampling, what we're sampling, and then through curatorial and institutional biases, such as what we're acquiring. And with institutional collections, there are many ways to introduce biases because many people are interacting with those collections. And this might affect work that is done with collections, whether that is research or public education. Now, anthropogenic biases have been discussed with other collections, botany, paleontology, mostly biological collections. And if you remember last year's plenary talk by Dr. Louise Rocha, he spoke about the sampling of a specific oceanic zone that was too deep for scuba diving, but too shallow for submarine work, which caused some undersampling in that oceanic zone. And I also should note that there's been work done on understanding biases due to racism and colonialism that are biases in collections. Now, when it comes to mineral collections, anthropogenic biases haven't really been studied very much. There's a very brief note in Burbanek's 2023 paper on the preservation bias due to mineral hardness in earth sciences. So one of those big points that will introduce biases is the acquisition of minerals. So there's over 5,000 minerals in the world. How do you make those into a collection? So minerals are acquired by a variety of different ways. There's collection by staff, such as the calcite on the left, which was collected by me. I call it the Stegosaurus, and it's the ugliest of the specimens you're going to see in this talk, but I did pick it because it was the nicest out of them. You can also get specimens from donations, whether that's from the amateur community or from researchers, and also purchases from dealers where you can get a lot of display quality specimens. And minerals are acquired for different reasons, whether that is for scientific research, teaching, engaging the public in displays, or for historic value, heritage, or association with important people. And there are potential for these biases to be in the collections because of, let's say, research. People preferentially have in their research collections specimens that they are interested in. So if someone is looking, for example, apatite, they're going to be picking maybe mines that have a lot of them. They'll be preferentially picking that out of the ground, causing some overrepresentation. And we're going to be seeing probably in the future more maybe critical minerals bearing specimens because of that importance right now in our society. So a lot of research is in around mining, but you also will see some biases towards rare specimens because there are some specimens that, or some minerals that only appear in a few areas around the world or just one, and even having a few of those will cause technically overrepresentation. Now, geography is going to be a source of bias, and through some other work that I've done in the past, it does have an impact on the collection. There's a strong bias towards specimens from near to the institution. There could be preferentially collecting from close by, a local network of people donating. There's a lot that kind of keeps it close to home, as you could say. So, for example, this is the Huntarian's Mineralogy and Petrology collection, and the light blue is specimens from Europe. And more than half of those are from Scotland and the UK, and that's not surprising because the Huntarian is in Scotland. And so even if you have other biases, geography will probably be intertwined with that. And there's also, if you could think about it, a bias towards minerals that appear close to the surface of the earth. We're not going that deep. And something that might be mined or close to the surface topologically. So to go on to mineral aesthetics. So minerals can be quite beautiful, like this calcite on the left that looks like it's swaying in the wind or something. And these aesthetics can make mineral collections a little different than other collections because it can be a strong force in what specimens you're acquiring. Now, not every mineral will be beautiful. There's a lot of lumps of quartz out there, but you tend to pick the ones that you think are pretty. So what goes into mineral aesthetics are things like color. So someone might like a bright red tourmaline over a black one, You'll be looking at something like the shape or form of a specimen. So is there more than one crystal? Are the crystals terminated? Is it an array? And the combination with accessory minerals. Is there a nice contrast in color? Do they highlight the main mineral? The luster, or so how it reflects the light and how it can be eye-catching. And then pretty much the overall composition. So how do all these things work together to make something beautiful and a natural work of art? And aesthetics are subjective. We all have a soft spot for something, and it might overlap a bit with your science interests. I'm personally a huge fan of dissolution textures. I love the color green, and a fondness for pyrite because of childhood memories. And so you'll preferentially like different things. And as a staff at a museum or another institution choosing what minerals go into a collection, you might have a bias towards one thing or another, such as, choosing between the two cerandites on the left. You might prefer one over the other if you only have room for one. Now, this can impact the mineral collections because, again, not every specimen must be beautiful, but if someone is collecting in a quarry or something like that, and they're picking something out of the earth, they're probably going to keep the thing that looks the nicest. And whether a curator is purchasing from dealers, they will also be probably picking something that they think is the nicest for their price point. So while looking at the Earth's crust has, over half of it's made up of the mineral group feldspar, pretty much. And if you look at mineral collections, they're not made up of over half of them being feldspar. Even if we look at the left here, there's labradorite, which makes a beautiful thing called labradorescence. When it's nice and polished, it will probably be overrepresented in the collection because it is prettier than some of the other minerals in terms of how much abundance it is compared to other feldspars. When I did look at the Hunterian's collection, looking at different feldspars, which brought up both minerals and the rock collection, they only was about 4% of the collection, which is far less than half. So you'll also see overrepresentation in certain localities, as some will be considered prettier than others. Let's say the right-hand side is rhodochrosite from the Alma mine, which is known for its very cherry red, beautiful rhombs of rhodochrosite. So those will probably be overrepresented because they're mining that to sell pretty specimens, and those specimens like those will be preferentially in the market because they can make more money, and they'll sell well. So again, that adds another layer to these biases. So how can these impact the use of the collection? So it's hard to argue not to use pretty ones for displays, but it might impact something like research, where there might be an overemphasis on textures that might be considered beautiful, and any sort of big data coming off of collection information will have its own biases in its own way. So a very big thank you, and I hope you have a good rest of the conference.
Thank you, Erica. Erica is online if anyone has questions or comments. Yes, please.
Hi, Erica. Mike here. Sorry, I'm an old colleague of Erica's, so nice to chat with her. We just wanted to sort of say thanks for the talk, but there's probably similar problems in zoology collections where there's a bias towards, say, prettier coloured male birds or bigger specimens of mammals, and the similar sorts of problems where the rarer stuff is collected and the common things are just ignored. So yes, it's a problem throughout the natural sciences, I think. Yeah, but thank you for the talk.
Can you hear me?
Yes.
Hi. Thanks, Mike. Yes, I agree. And I think I just saw a botany paper that was talking about how they, preferentially pick flowering plants because they're prettier. So it's certainly something that is seen throughout some of the other collections, as well as you think paleontology, you're going to pick, a full skull if you're going to spend a summer taking something out of the ground compared to fragments if you have the choice. So I definitely think that it's going to be seen in other natural history collections.
Okay, there's no more any other comments or questions. Okay, unfortunately, I haven't seen two of the speakers online. And for people who just joined us in the room and also online, we couldn't get the recording of the last two presenters, from the last two presenters. So I guess we can end the session early and take this opportunity to go to other room for other talks. Okay, yeah. So thank you, everyone. Thank you, everyone online as well.